Hey everyone, in this video, I'm going to be going over the legal problem, implement trie. So first, let's read the question. A trie or prefix tree is a tree data structure used to efficiently store and retrieve keys in a data set of strings. There are various applications of this data structure, such as autocomplete and spell checker. So we're going to implement the trie class. So this will initialize the trie object, and we're going to basically be implementing three functions. The first function is insert. So insert takes in a string word and inserts the word into the trie. The next function is search. So search takes in a string word and returns true if the string word is in a trie, i.e. it was inserted before, and false otherwise. And the last function we're going to implement is starts with, that takes in a string prefix. It returns true if there's a previously inserted word that has the prefix, and false otherwise. And some constraints on the inputs are that both word and prefix has at least one character, so you won't get any like blank inputs. And both word and prefix consist only of lowercase English letters. So I'm gonna explain what a prefix tree or a trie is. So suppose that we are gonna we want to insert this word apple into a trie. So it's gonna look something like this. So basically, you're gonna have a root which is pretty much empty, and then for each character in the word, if that character isn't already in the trie, you're gonna make a new node, store that character, and just basically repeat. And the final part is that once we get to the last character, we have to add like a special mark to show that that's the last character of this word. So in this case, we see that this E is the last letter of apple. So I'm gonna just mark it like this, like give an underline to show that this is the last to show that this is the last letter of the word apple. And now let's say, suppose we want to search for the word apple, right? Like we just did an example of insert. Now let's say we want to search the word apple. What we would do is like, again, for each letter in the word, let me just do, hold on one second. Let me just do this. And now we want to search apple, right? We want to search for the word apple. What's going to happen is that we're going to loop through each character of this word, and we're going to see if it exists in the trie. At any point, if we realize that this like one of the letters in this word does not exist in the trie, we return false. And let's say like we go through all the letters in the word, right? The final step we have to do is we have to make sure that the last letter is marked specially. So for example, right, like this E, we want to make sure that this E is marked specially to indicate that it's the last letter of the word. Because you might have something like this, right? Like let's say you previously inserted the word apples, for example, right? So again, it's gonna look something like this. But this time, instead of the E being the having the special mark, it will be the S, right? Because the last letter is now S. So in this case, the word we inserted is apples, not apple. So if we were to search apple in this, it will return false, right? Because apples was inserted before, not apple. And the last function that we're going to talk about is starts with, right? So starts with, let's say we want to see if there's any word in a trie that starts with app, for example. Starts with is a lot similar to search. Basically, you just keep going through each letter of the word and checking to see if it exists in the trie. So like it'll check if A exists, and then it'll check if P is a child of A, and it'll check if P is a child of this P. And if all the letters exist in that sequence, you return true. Otherwise, you return false. You don't have to worry about checking if the last letter is marked or anything, right? Because this one starts with. We don't care if like the last, like in this case, we don't care if like if P is the last letter, right? We just care like that there's like a sequence of letters that have this that has APP. So with that being said, let me go back to the code and code this out. So the first thing that we're gonna do is we're actually gonna make class called node. So let me move the mouse. So we're gonna have a class called node, and in for node, we're gonna take like two things. So we're gonna have two things. The first one is the children. So oops, sorry. So how I'm gonna do this is the children is gonna be a Python dictionary or hash map. The key will be the individual letter, and the value will be another node object. So basically, basically this children, this just stores all the children a node has basically in this like hash map fashion. And the second thing we're gonna have is the mark, right? I'm gonna call the mark last letter, and I'm gonna initialize it to false. So this last letter, this is the special marking I mentioned here and here, right? Like we need to make sure that we know where the last letter of the inserted word is. So it's going to be initialized to false, and then later on we can like update it to true if we reach the last letter. So for init, I'm gonna create a root node, and this will be it. No, sorry. I know for insert, right? So for insert, what I'm gonna do is I'm gonna loop through every letter of the import word, like of this word. If it doesn't already exist in the like in a path, we add it. If it does exist, we don't add it again, right? For example, like let me scroll down a bit. So let's say that we have this word, like let's say we have this, right? Let's say we have apples. So apple listed in a tree, right? Like let's say we do insert apple here, right? If we were to do another word, let's say app, we're not gonna make another like branch, right? Like this. Sorry. We're not gonna make another branch like this. Instead, we're gonna see, okay, does this A exist here? It does. Does this P exist after the A? It does. Does this P exist after this P? It does. So we just mark this as the last node. There's no need to like have another separate branch altogether. So, like I mentioned, we're gonna loop through every letter of the word. If that letter is not in the path or sequence, we'll add it. If it is, we'll just continue. So, oops, sorry. So here I'm gonna make like a variable that calls like self.root. And I'm gonna loop through this word. And oops, sorry. And if this chart is not in the hash map of like this node's like children hash map, then we'll add it. So right, so like I mentioned, the key will be the letter and the value will be another node object. And then we're gonna basically like update this node variable to be that children node. And finally, once we insert the last letter, we're gonna update. I just copy this. We're gonna set the last letter marking to be true. So let me just reiterate. For insert, right, we loop through every character in the word. If that character is not in the child list of the previous node, we add it in. If it is, we just continue. And finally, once we reach the last letter, we mark it as the last letter by doing this like node.last letter equals to true. So this is insert. I'm gonna do search now, and search is very it's kind of similar to insert. So I'm just copy some of this code. So again, right, for search, again, we're gonna loop through every character of the word. And if we at any point realize that like one of the characters is not in the sequence, we return false. Right? So that's what I'm doing here. If the character is not in the like previous node's children list, then we return false. Otherwise, we keep, I'll just copy this again. Otherwise, we keep going. And finally, after we've looped through all the letters in the word, and all of them exist in the same sequence or order, we need to check if the last letter is specially marked. So we're gonna return node the last letter. So if this value is true, that means that we know that the last letter in this word is the actual last letter of like another word that was previously inserted. Otherwise, if it's false, then we know like maybe this word is like a shorter version of another word that was inserted before. Again, like if I go back to here, right, we see like the apples and apple example, right? The word we inserted was apples, but when we search for apple, even though the letters exist in like the same sequence order, because this E isn't marked as the last letter, we can't say that we inserted apple before, right? And finally, again, let me just copy this. For starts with, it's very similar to search, like I mentioned before. So the only difference is that instead of returning no last letter, we just return true. Because like I mentioned before, right? For starts with, we only care if there's like a sequence of letters in that particular order in the trie, right? We don't care if like the last letter in prefix. Oh, I also have changes to prefix. We don't care if the last letter in prefix is the last letter of a special word. Let me just double check that I didn't miss anything, like mistype anything. It should be fine. I'm just doing a double check. Okay, it looks fine. Let me just do a quick test run. Looks good. And let me submit this. And yep, you can see this is a valid solution and it's pretty efficient. Thank you all for watching. I hope you learned something.